Hello class, we want to begin. This is our last lecture in chemistry. We've already finished biophysics lectures. Let's begin. Redox reactions. Oxidation reduction reactions. We have an acronym for it. Leo says J. We'll get to understand this as we move on. As part of the study objectives, we want to define what oxidation and reduction in terms of the loss or gain of oxygen, that is either oxidation or reduction, is the loss or gain of oxygen, loss or gain of protons, and the loss or gain of electrons. We want to state the characteristics of a redox reaction and identify the oxidizing agent and the reducing agent. We want to also describe what happens to iron when it corrodes. So the last objective will be on corrosion. Oxidation and reduction. Early chemists. A chemist is somebody who did chemistry, a scientist with chemistry background. So early chemists saw oxidation reactions only as the combination of a material with oxygen to produce an oxide. When oxygen combines with any material, it produces an oxide. For example, when methane, which is CH4, burns in air, it oxidizes and forms oxides of carbon and hydrogen. So methane is CH4. That means when it oxidizes in air, it will form carbon monoxide and also water and the rest. Let's continue. But not all oxidation processes that uses oxygen involve burning. Meaning that, when you light a candle or you are burning something and you cover that thing with a basin, all of a sudden the fire will go out. But when you leave the basin, it will start to burn again. Meaning that oxidation or oxygenation, when you provide oxygen gas, it promotes burning of materials. So this is the assumption or the hypothesis or what early scientists believed. The oxidation is only burning, but that is not certainly it. It's burning, but it's not like that in all cases. Elemental iron slowly oxidizes to compounds such as iron 3 oxide, commonly called rust. So we cannot say rust or something rusty, a metal rusting is burning. No, but it's an ion that has been conjugated or combined with oxygen to form iron 3 oxide. But that is not burning. Rust is not. It's not like you are burning charcoal or firewood. When a bleach is like parasol, so when you have a stain in your dress, fabric is the same as dress, and you use a parasol or a bleach, Omo and the rest, to remove the stain, there is also oxidation over here. So later you will get to know that oxidation is what? The removal of electrons, whereas reduction is the addition of electrons. Oxidation is also the removal of what? Protons, whereas reduction is the addition of protons. Let's continue. So hydrogen peroxide is H2O2, also releases oxygen when it decomposes. So we cannot say this is burning. We continue by saying that a process called reduction is the opposite of oxidation, and originally meant the loss of oxygen from a compound. At first, that was the only assumption. Oxidation and reduction always occur at the same time. It's like the what do you say? Redox reaction. It's redox reaction. It occurs, oxidation and reduction occurs at the same time. It's like the equilibrium reaction. So redox reactions, they have a double arrow, the forward reaction and the backward reaction. So it occurs at the same time. We will see examples very soon. The substance gaining oxygen, or losing electrons or losing protons is oxidized. The substance gaining oxygen, losing electrons or losing protons is said to be oxidized, while the substance losing oxygen, the first was gaining, but now losing oxygen, gaining electrons or gaining protons, is reduced. So when you add a proton or an acid to a medium, you have reduced the medium. Today, many of these reactions may not even involve oxygen. Redox currently says that electrons are transferred between reactants. So let's see over here with this example. Magnesium plus sulfur. Magnesium loses 2 electrons and gives these 2 electrons to sulfur, which does not even need any electron from magnesium. So magnesium becomes 2 plus because it has lost 2 electrons in its outermost shell and has given those 2 electrons to sulfur. So sulfur is now having 2s raised to the power 2 minus. The 2 minus is the 2 electrons that it has gained from magnesium. So magnesium lost the 2 electrons, so it became what? 2 pluses, while sulfur gained the 2 electrons and became 2 minus. So the magnesium atom, which has 0 charge, it has 0 charge over here, changes to magnesium ion by losing 2 electrons. So it changes to magnesium ion by losing 2 electrons, and by this magnesium ion is said to be what? Oxidized. You can recall or remember that oxidation is the removal of electrons. So when it removed the 2 electrons and gave it to sulfur, then it became oxidized. The sulfur atom, which has no charge over here, is changed to sulfide ion over here by gaining 2 electrons. So it gained the 2 electrons by gaining 2 electrons from magnesium. And so by this, because it has gained 2 electrons from magnesium, sulfur is said to have been what? Reduced. Okay, so we have oxidation, reduction, reaction continues. So 2 sodium atoms loses 1 electron. So 2 sodium atoms will lose 1 electron. So they will lose 1 electron each. So 2 sodium atoms, 2 chloride or chlorine atoms. So 1 sodium atom will lose 1 electron to become 1 plus. But remember there are 2 over here. So 2 sodium 1 plus. Then remember also that the chlorines are 2. Chlorines are 2. So the chlorines will also gain these 2 electrons, 1 each from each sodium. The chlorines will take 1 electron each from each sodium to become -1. Remember, chlorine is 2 because 2 times chlorine will give us 2 chlorines. 2 times sodium will give us 2 sodium. So sodium loses 1 plus, chlorine gains that electron, becomes -1. So it has been explained here. We have sodium 0, then sodium loses an electron to become sodium 1 plus. Each chlorine atom gains 1 electron, so chlorine is 0 plus electron will become chlorine minus. So this is an acronym. Lose electrons is equal to oxidation. So we see sodium loses an electron, sodium becomes what? Oxidized. When you gain electrons, you become reduced. Chlorine gains electron to become chloride or chlorine minus. Chlorine is reduced. So let's explain it further. Losing electrons is oxidation, and the substance that loses the electrons is called in the opposite way as reducing agent. Why is it reducing agent? Because it's giving its electrons to another atom, so it's reducing. When you gain electron, you become reduced. So the agent that is causing another electron to become reduced is called the reducing agent. So when you lose your electrons, you yourself become oxidized, and the substance that, or the element or the atom that loses the electron is called the reducing agent, because that atom itself becomes oxidized because it has lost electron. And when it gives it to another atom or element, that element becomes reduced. So the one losing the electron becomes oxidized, and the element or atom that it gives the electron to becomes reduced. So the agent that is causing another element to become reduced is called reducing agent. In the opposite, gaining electrons is reduction, and the substance that gains the electrons is called the oxidizing agent, because when you gain electrons, you are parasiting. Somebody has electrons and you took it from the person by force. So you yourself, you become reduced, but the other one electron or the other element or atom that you forcefully collected electrons from, that substance becomes what? Oxidized. So you, the one that is taking the electrons from that substance, you are the oxidizing agent. Because when you take the electrons from that substance, you make that substance very poor. So you have oxidized that substance or that element or atom, and you yourself become what? Reduced. So gaining electrons is reduction, and the substance that gains the electrons is called the oxidizing agent. Let's see by example. Magnesium to magnesium plus. Magnesium is oxidized. Why is it oxidized? It loses 2 electrons. It loses 2 electrons to form magnesium sulfide. So magnesium will be oxidized and become magnesium 2 pluses. Let's go here. So you can see magnesium. Okay, so if magnesium is oxidized, meaning that it loses 2 electrons from its outermost shell, so it becomes oxidized. Then Magnesium gives these 2 electrons to sulfur, so that sulfur will become what? Reduced. It gets 2 electrons. So magnesium over here is called the reducing agent, because it donated 2 electrons to the sulfur, so that it will, and when you gain electrons you become reduced. So magnesium causes reduction of sulfur to sulfur 2 minus. What about if magnesium takes back these 2 electrons? He said that magnesium will say, I'm very angry, I want to take back my electrons, you are owing me, give it to me. Then by force takes back these 2 electrons from sulfur to become magnesium atom. Then when magnesium takes back the 2 electrons, magnesium becomes reduced, so it will become this magnesium. Then sulfur will lose these 2 electrons and become what? Sulfur. So sulfur, by losing its electrons, becomes oxidized. The magnesium that forced sulfur and collected back its own electron becomes reduced. So now which agent caused sulfur to lose its 2 electrons in the outermost shell? It's magnesium. So magnesium 2 plus becomes an oxidizing agent, because it causes sulfur to be oxidized by releasing its 2 electrons. It is easy to see the loss and gain of electrons in ionic compounds, but what about covalent compounds? In water molecule, oxygen is highly electronegative. That means that it is very negative, so it attracts charges. It attracts the positive charges. The oxygen gains electrons. When oxygen gains electrons, it's reduced and is the oxidizing agent. And the hydrogen, that is, we are talking about water molecule, H2O, and the hydrogen loses electrons. So when hydrogen loses electrons, it becomes what? Oxidized, and is the reducing agent, as explained. Reactions in which there has been no change in oxidation number are not redox reactions. Examples. Over here we can see this one, oxidation number is the same, 1 plus. Nitrogen is plus 5. Nitrogen plus 5. Chlorine minus 1. Oxygen minus 2. So there has not been any change in oxidation number from reactant to product. So we say that this is not a redox reaction, because there should be a change in oxidation number. The same applies to the one below. Damage done to metal is costly to prevent and repair. Iron, a common construction metal often used in forming steel alloys, corrodes by being oxidized to ions of iron by oxygen. This corrosion is even faster in the presence of salts and acids, because these materials make electrically conductive solutions that make electron transfer easy. Luckily, not all metals corrode easily. Gold and platinum are called noble metals because they are resistant to losing their electrons by corrosion. Other metals may lose their electrons easily, but are protected from corrosion by the oxide coating on their surface, such as aluminium. So when you coat aluminium with oxide coating, it prevents rusting or corrosion. Iron has an oxide coating, but it is not tightly packed, so water and air can penetrate it easily. Serious problems can result if breaches, storage tanks or hulls of ships corrode. When bridges corrode, like the Yapi or Bupe bridge, if the metals there corrode, you know what will happen? Buses and cars will now fall from the bridge into the sea, the white water or the black water. So corrosion is a very serious thing. And corrosion can be prevented by coating of oil. If you have some metal in the house, or you have your bicycle and you don't paint it, you don't coat it with oil, your keys, coat your keys with oil. And when you coat with plastic or even another metal, it prevents corrosion. If this surface is scratched or worn away, the paint is scratched, oil is worn away, plastic is scratched, the protection is lost. So make sure that if you paint a metal, or you see that those big bridges, they most of the time paint and repaint it again, so that it will not lose its protection, so that it will not cause the original metal or the iron to corrode. Other methods of prevention involve the sacrifice of one metal to save the second. Magnesium, chromium, or even zinc can be used to coat other metals, and this process is called galvanization. End of lecture. Hope to see you in the next quiz. I'm going to combine redox and also equilibrium together as quiz. We will discuss this further in class. Thank you.